Okay, this morning we're going to put together a video for the chapter 16, horizontal curves. I have sent you quite a few links already from YouTube that would allow you to get the concepts fairly well, not embedded, but at least you're familiar with the concepts. So I thought today what I would do is take a problem and take the concepts that you've been exposed to through me a little bit and through YouTube, me a little bit, meaning before we took break, and see if I can put them all together so it makes sense to you. So it's a horizontal curve. We're in chapter 16 of your text, and here's pretty typical of what you're going to see on a test and what you would have seen in the lab. So here I've got a curve, and the curve has got these properties. Interior angle, 36 degrees, 48 minutes, 20 seconds. It's got a radius of 160 feet. It's got a beginning station, the BC station. BC, the beginning of the curve, which is also the point of curvature, or PC. They're both interchangeable, as you probably saw in the videos, is at 9 plus 10. So we're at station 910. Okay, and then it asks us to find the parts of the curve, and it also asks us to find out how you're going to lay out. So I need deflection angles and chords in order to lay it out. So we're going to go first through it, and we're going to gather some information that we may need in the field, like the middle ordinate and the external, the tangent length, and those types of things. So the layout says, determine the stations of the PI and EC. So first thing I'm going to do is determine stations of the PI and the end of the curve. And I'm also going to find the station of the middle of the curve. So I'm going to put here center line of curve. So I need those stations. And it also asks me to find parts. And the parts it's asked me to find are these. The parts. The tangent, the long chord, the length of the curve, the middle ordinate, the external, and the degree of curvature. So we're going to first find those parts, and then the second part of the problem is set up a table that you can take to the field to physically lay this thing out. So let's go about it. So I got a curve. Here's my curve. Curve has a radius. It has tangents. And the tangents cross at the PI. It's got a beginning, and it says that's 9 plus 10. It's got a PI, it's got an end. Given I was 36, 48, 20. Radius, 160 feet. This is a relatively short curve. The reason it is because this is a curve that I used in class to lay out in the field, and we laid it out in the field to the east of the building, and of course that field is not that large. So these numbers are going to be relatively small, designed that way to fit the property we have. So let's go about it. First thing, let's find the stations of each of the critical points. So how am I going to find them? PI. If I take the beginning of the curve and add the tangent to it, I've got the PI. So PI equals the beginning of the curve plus the tangent length. Takes care of one of them. Second one, end of the curve. If I take the beginning of the curve and I add the length of the curve to it, I've got the end of the curve. So the end of the curve is equal to the beginning of the curve plus the length of the curve. And then the middle of the curve, which is right here, if I start at the beginning and I add half the length of the curve, I've got the middle of the curve. So center line, beginning of the curve plus the length of the curve divided by 2. So in this particular unit, the BC is 9 plus 10. So all three of those are 9 plus 10. So I need the tangent. So the first thing is to find the equation for tangent. And if you went to your book and you looked a little bit, on page 16.8 is a tangent equation, r tangent of I over 2. So T equals r tan of I over 2. Okay, I've already got r right here. And I took this number right here and I changed it into a decimal. And when I did that, it was 36.80 and a bunch of 5s. So this guy is 36.80 and a bunch of 5s. That was just like you did on the test. Put 36.48.20 into your calculator. So if you happen to have this guy handy, I put 36.48.20, convert, and it's 36.80555. So there's so I'm going to put 36.80555 over 2. And when I calculate that, I ended up with a value that was 53.23 feet. Okay, so for the first one, if I take 9 plus 10 and I add 53.23 feet to it, it looks like it's good, or subtract, add. I'm good. It's 9 plus 63.23. So 9. There's the station of the PI. Now I need the length. If I got the length, I can put the whole length in the first equation, half the length in the second equation, and I've got the end of the curve and the center line. So let's go length of curve. Equation for that. Hopefully you remember this. 2 pi r is to 360 as L is to I. So r is 160 again. This is 36.80 and a bunch of 5s. And if you do the math for that particular one, let me find it here. You find out the length is actually equal to 102.78. 102.78 feet. So put him right here. And put him right here. So I'm going to use my calculator. I'm going to take, and we said we get rid of the plus, add them, and put the plus back in. So I'm going to put my 910 plus 102.78. I get 1012.78. Put the plus back in. There's the end. And now the second one, I'll take the 910. I'll add to it 102.78 divided by 2, and I get 961.39. Put the plus back in. So this station right here is 9 plus 61.39, and this station right here is 10 plus 12.78. So that takes care of this, this, and this. And I've already got 2 of these figured out. I got this one figured out, and I've got this one figured out. So I've got 4 more things to worry about. the long chord, the middle ordinate, E and dA. So I'm going to draw them. Here's the long chord. Okay, I'm going to get something that's got a little more ink in it. There's the long chord. There's the middle ordinate. There's E. And hopefully you got out of the videos and my lectures that dA, the degree of curvature, is the angle subtended by an arc length of 100 feet. So if I've got 100 foot of this arc, whatever angle's on the end of that is the dA. So let's finish them off. If you go to your text, now I've got those numbers all put up there so I can erase this. If you go to your text and you pull out a couple equations, I'll follow right down the line. First one is long chord. So let's do that. Go to your text. And in the text, if you go to, okay, where are you, little guy? You're right here somewhere. You go to page 16-9 near the top. LC is equal to 2R sine I over 2. Long chord is equal to 2R sine of I over 2. And if you push those through your calculator, I got a number of 101.02 feet. 101.02 feet. Does it make sense? The length of the curve is 102.78. That's going on the arc. Going straight across has got to be a little less. 101 is a little less than 102, so may not be right, but it's a good number. Takes care of this. MO. Find the equation. The equation is written in your book. It is on page 1611, very top. R minus R cosine I over 2. R minus R cosine of I over 2. 160. 160. Cosine 36 over 2. If you multiply the right side all together and then subtract it from 160, you get 818. 8.18 feet. So the distance between a stake right on the center of the long chord to a stake at the center of the curve has got a distance of a little over 8 feet, 8.18 feet. Takes care of this guy. Next one is the external. Grab the equation. External is on page 1610, R over cosine I over 2 minus R. R cosine I over 2 minus R. 160, 160, 36.805 divided by 2. You take and multiply this stuff and divide the values into multiply cosine times that angle, divide it into 160, and then subtract it from 160. You get an external of 8.62 feet. Takes care of this one. So if I had to put numbers up here, this distance right here is 8.18, and this distance right here is 8.62. Okay, the long chord is 101.02. The length of the curve is 102.78. I've got the stations written there. That leaves me one thing left, and that's the dA, degree of curvature, and that's an expansion of this formula. So if I put dA, we said dA is a angle created that gives me a curve of 100 feet when I send it out. So if I use these two guys right here, I can take 2 pi times 160, divide it by 360, and move that back to the other side and divide it into 100. And let me see if I did that. I may not have done that. Yes, I did. That comes out to be 35. 80986. Same as you did on your test. Put that in decimal form, push degrees, minutes, seconds, and you end up with 35 degrees, 48 minutes, 36 seconds. So that makes pretty much sense. 102 foot of arc has this angle. 100 is just a baby little fraction less than that, and that angle is a degree less than that one. So the answers make sense. So this is how you go about finding parts. Remember when we did the problem in class before break, I put a triangle right here. There was my triangle. One was right there, and another one was right here. If you know how to deal with those two triangles, every one of those equations falls out. All it is circle geometry. Okay? Draw some angles, make triangles, and then use a little trig, and you should have your answers. So that's the first part. First part was find the parts. So I've got a curve over here. I'm going to get rid of this. And then we're going to go ahead and figure out how we're going to lay this little baby out. I'm going to get rid of this stuff. Everything is over there that I need except one, and I'll write him down right now. This is so that's that in decimal form. Okay, I'm going to draw a curve, and then I'm going to go ahead and use that curve to develop a table. So here's my curve. I'm going to draw it pretty big so you can see it. This is the same curve as that one over there. This is station 910. Okay, this is station 10, 12, 78.